Hello everyone, welcome to NumPy course. So today's session will be learning towards the concept of binary operators. As you observe there, we are talking about the binary operators. We'll start with the types of binary operator. Before that, what do you mean by binary operator? As you know that in a computer science, we call binary is nothing but will support either true or false. Here also it will be working as a bit by bit. So binary operation means always work as bit by bit. We call as a binary operator acts on bits and performance bit by bit operation. Just now I told you it's perform a bit by bit operation. This is nothing but your binary operations. Binary operation is a way of rule of combining the two values to create a new values. So whenever we use this binary operation, we are trying to combining the two values and will create a particular new value in that. So let's move to the types of binary operation. Those are nothing but the types of binary operation. We'll start with the bitwise and then bitwise or XOR, left shift, right shift, inverter. So bitwise and is nothing but just a function is used to this we call about bitwise and it is nothing but just a function is used to compute your using a bitwise and operation. Now move to the truth table. So when you are going with the logic gates, we're having some truth table, right? Logic gates. So we learn this thing in a physics, normal physics concept in standard 11 and 12. The logic gates concept where we learn that AND gate, and then we use a OR gate, and then we use XOR gate, and then we are using a NOT gate, right? So this particular logic gate principle only it follows the your all this bitwise or XOR or inverter. The shift and right shift it's work differently. We'll discuss later wise. So bitwise and will follow the same logic gate and operator where we are having a input, then we are having a output, right? So in our input we are passing the two values here. So if the two values are true and true, so what will be the output? Then true false, then false true, then false false, right? We are following this truth table in it. So whenever we use a or, we'll use some dot operator. So whenever you use a dot operator, it's a x value, y value. So x dot y, which means that whenever we got true true, it means if 0 0 it true true true, then true false if 0 1, then also is 0. If you multiply it 0 0, and then if false false it's false. So true 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 false. So the same operation it follows by bitwise and or will be using the plus operator. Except of this dot operator, we use a plus operator in a bitwise or, and then the truth table will be different. Now move to XOR. So whenever we use a XOR method, that is also used for the same way, but it is a opposite of your OR. Suppose the AND of the OR. And then comes to inverter. This is nothing but your NOT, which is mean by the same way of your physics. What we use a logic get for the NOT. Suppose X and Y here 0 1 means it's true and false. So if you have a true means your output will be always false. If you have a false means your output will be true. That will be your input output. That comes to your invert. Then comes to your left shift and right shift. This is nothing but shifting from the left side, shifting from the right side of the values. It's always use, remember, two values mostly whenever you use and of and bitwise or XOR, it will be taking two values because when you do this operation of this particular truth table, then only you will get a answer or get a output on that. So this is how the binary operators works. So I hope you're clear with the theoretical way of your binary operator. Now we'll understand the practical how we'll use this operator in a Jupyter notebook. So let's jump to the Jupyter notebook to understand this. So we'll start with the importing part. So import numpy as np And then we'll move to just create or take a two variables because we have to work on the bitwise and operator. So I'm taking n1 equals to 20, then n2 equals to 60, and then continue with, we just want to print the values. In that print the values only, we have to see that what is the value of n1 and n2. So suppose print just nothing but n1. I just want to see what is the value of n1. So n1 equals to, and then comma of your n1, and then next print n2. We just want to see n2 values as well. So n2 equals to, then comma n2. Yeah, that is done. Now come to the main part here because we want to see the bitwise and operation. So suppose I'll put the name of sum equals to. Now what will be the alias name of numpy? We use np. So we'll go with np dot bitwise, and then we have to moving towards and operator because we are using and then we have to pass the both value, that is n1 comma n2. We are passing the values of n1 and n2, and then we just want to see that particular value as well. So we just run, before run we just print sum, nothing else. I just want to print sum. So we just run this. Now you can observe what will be the output. This is how you have to use our bitwise and, because whenever you use the two, whatever the value the first, because it's just to write 1 1, so the value will becomes in that particular area. Suppose you will use the same way you are using the in an array. Here I am using just normal values. The same function we are working with the array. Suppose take the same code, paste it here. Just which here we'll use array method. So we'll go with the 20 comma 40 and we just close it. It's done. The next also will do the same thing here. We are moving to the 60 comma 90 or 70. So it's done. The same way we just want to add it, we'll get the update. So this is how the bitwise and will work. Now move to see how the bitwise and will be work. See, the way will be the same. We have to take the same thing, just except of and we have to use in this particular area or. So you will get the answer what will be the supporting part of a or. The same way you can use for this particular as a array as well. When you have to take this, you are just going through, and in this particular you have to use this operation called bitwise or, and you can run. So XOR also the same way you can do it for XOR as well. So let's move to see that if you use invert, because that is for, this is for the two values, because invert is used for the one particular value. So we'll take a value n equals to 40, and then we just want to use this particular, first we want to print that value. So print your n equals to comma n1, and then we have to use that particular things. So I just use here display equals to and np, because you have to take from the numpy np dot, and then you have to use the method or operation invert invert, and then we are going towards to the variable name and1, and then we can print the display. Just I'm giving the display method where we store it. Yeah, we can run this particular one. Oh, it's print. Yeah, you can run this, you'll get a -4, because invert is the opposite of that, right? It's a reverse one. So whenever we use this, we'll get like this. Inversion of 10 is -41, because whatever the value we'll take, it will be inverting, it will be doing -1, we'll be adding that particular way, so we'll get a -41 for the all the values. It's not like that only for 40. If you choose here, suppose you choose here 20, you will get -21. You can observe this is the operation of your inversion. Whenever we use this, the inversion. Now whenever you do the shifting, I'll show you one more example, that is nothing but your shifting one. So we are taking the same value, just to take the same value, just to use the inversion. So display, so this is also we have to shift, we'll use the how many bit you want to shift it, that also you have to use here. So suppose I want to use 3 shift or 2 shift here. So I used here 2 shift. Then you have to print the particular things. If you want to print the both, you can print it. So I'm just printing the both. Print equals to the shifting also. So shift, how many shift we give. So we give that particular thing and name is shift. So we give the shift. That's all. Then move to use this display method, but you can use any variable name here. And then np dot left shift. So we use left shift method, left shift shift, and then you have to pass the value, whatever the variable name you give for that, you have to give that value, as well as remember you have to give the shift value as well, because you have to do the shifting here. So we give the shift value and then just print, and you just give the particular variable name where we save the shifting value, you will get that particular output. So this is how you have to use the binary operation in numpy.